We're now going to answer part B of this question, which says we need to state a largest possible restricted domain such that an inverse function exists for t of x. State your answer correct to one decimal place. Okay, so for an inverse function to exist, what is this saying? This is kind of like code. This is saying it must be 1, 2, 1. That's what it's telling me. It must be 1 to 1. So if we look up here, we need to make this blue graph here 1 to 1, but we also need to take note of the fact that we need to state the largest possible restricted domain such that it's 1 to 1. So we're going to have to find the maximum here. We can do this using the graphing section because it says it can be correct to one decimal place. So menu, analyze, maximum of the red graph from here to here. And as you can see, it's 2.5. So this point right here is 2.5, 2.5, 12.25. So therefore, if I wanted to state the largest possible restricted domain, I could say that x is an element of 2.5, and actually I would have to include it. I would have to include 2.5 and go to infinity. Or x is an element of, now you don't have to provide both of these, and I'm actually running out of space here, so let me just try this again. So x is an element of 2.5 to infinity, or you could say x is an element of negative infinity to 2.5, close that off. And hopefully you can see there, if I was to ignore half of this graph, so imagine ignoring half of it, I've created the largest possible domain such that when I put a horizontal line, it only touches it once. So that's what we've achieved by restricting it. So we're finding that value right there. Okay, that's it. So state the largest possible restricted domain such that an inverse exists. It must be 1 to 1. And there it is. Hopefully you found this helpful.